Today's lesson is on the relationship between the graphs of a function and its derivative. A derivative function is always the slope of the original function. So you might want to keep it in mind. It's the slope of the tangent line at every single point on that function. A couple of things that we know about the function if we know about their derivative. If a derivative, this is supposed to say f prime of x, I'm not sure if you can read it. If a derivative is negative, then that means that the function is decreasing. If a derivative is positive at any point, that means that the function is increasing. If a derivative is 0, that means the function is stopped. It also means that at that point, the x point of the derivative, there is a horizontal tangent, which can indicate that there is a maximum value at that point, or that there is a minimum value at that point. Okay, so that is a little bit about what we know about the function from the graphs. Now let's do a few examples. Given a graph of a derivative, sketch a graph of the function. All right, here is our derivative graph. And we have our function graph that we haven't built in yet. This is our derivative graph. This is our function graph. All right, so the derivative graph says that anything less than x equals 1 has a slope of -1. Anything greater than +1 has a slope of +1. And the first thing they give us is that there is a point on our function graph, 1, -1. So draw that point. That's a given. 1, -1. All right, to the left, or less than 1, we have a slope everywhere of -1. So draw a line with a slope of -1. We also are told that this is continuous. Okay, the function's continuous, and this is the graph of the derivative. So we know we're not going to pick up our pen across the function graph. On the right-hand side, or the positive side of x equals 1, the slope is equal to 1. So we are going to draw a line with slope of 1, and it is a constant slope. So every point on the left-hand side of 1 has a -1 slope. Every point on the right hand has a +1 slope. Another example is given a function as a piecewise function. Draw it. That's your derivative graph. Again, this is your derivative function. And you're asked to draw the original function from that. And you're given a point again. All right, so let's start by drawing the derivative graph. This graph has boundaries at x equals 4. So everything less than x equals 4, the derivative is 2. So I'm going to draw that this function equals 2 everywhere less than 4. Everywhere greater than 4, it equals -2. So let's draw our given point, 4, 3. Everything less than x equals 4 is going to be a +2. Everything greater than 4 is going to be a -2. If you want to draw this more precisely, you can actually draw points going down with a -2 slope. That is the graph of the function given this derivative and a starting point, an initial value. This is sometimes called your initial value. And look for those, because you can always graph those points to get you started. Last but not least, well, almost last, given a graph of the function, sketch a graph of the derivative. Here, so this time we're going backwards. We're starting with a function graph. we want to draw a graph of the slopes. So let's start. This graph goes from -4 to x equals 5. So from -4 to 5, we want to draw a graph. Okay, the slope between -4 and -2 is equal to a -1. And you can rise over run to find that the slope is -1. So right here is -4, -2. In between here, you're going to have a slope of -1. That was right. -1. So that's a constant slope between there. Now we put a closed point at the end point and an open circle at the interior point. And we'll talk more about open and closed circles as we go along. Between 2 and -2, we have a 0 slope. So let's draw those. These are supposed to be open circles across there. We have another -1 slope between 2 and 4. Positive 2 and 4. And here we have a rise over run of 4. So the slope between 4 and 5 is going to be 4. So we're going to put a little teeny segment right here. This is the graph of the slope. All right, that is the slope of each of these segments of your original graph. That's how we would graph the derivative. All right, this is the last one where we have given a graph function x ln of x minus x. This is your function, and this is also a homework problem you'll have. Pick out which function is the derivative of the function for x greater than 0. So we have graphed this function that they gave us, and this was a multiple choice question. So you have 5 options. Is the derivative function sine, ln, square root of x, x squared, or a line? So I like to draw what these functions look like. This sine function goes up and down, up and down, up and down. So it increases, decreases, increases, decreases. Okay, so, and it goes, because the decreasing parts are below the line, increasing are above. Ln of x kind of starts right here and grows steadily. The square root of x kind of does the same thing, doesn't it? X squared goes up like this, and a line goes like this. All right, so now we have kind of a picture in our mind of what those 5 options are. Our graph tells us that when we graph this, and you can use your graphing calculator to graph this, you have a point right here at 1, -1. That is the minimum point on this graph. That means that there is a horizontal tangent right there. So when I am graphing my slope graph, I know that x equals 1, there is a slope of 0. All right? Now, from 0 to 1, you have a decreasing slope. So you know that your graph must be below the line. Okay? And it actually starts higher and then goes towards 0. Then you have an increasing function from 1 on. So somehow your graph is going to go up and go on indefinitely. And it seems to kind of level out near some slope. Maybe it doesn't have a tangent up there, but it seems to level out. All right, so looking at this graph, we can kind of eliminate some of the options just by looking. But one thing to note is that we have one certain point here, 1, 0. So what we can do is test this point in all 4 or all 5 of these functions. All right, so 1, 0 does not work in sine. It does work in ln. 1, 0 does not work in a square root function. 1, 0 does not work in y equals x squared, and 1, 0 doesn't work in that line equation. So our answer must be, just based on that one point, our minimum, that y equals ln of x. And that is the end of our derivative graphs lesson.